All right, gang. So today we want to talk about the importance of regulating calcium. When we start looking at all of the remodeling that's going on in the bones, one of the reasons why we have remodeling occurring is to maintain correct calcium ion balance in the blood. And so I want to just give you 5 quick reasons why that is important to do. The first one is we need skeletal muscle contractions to be occurring, and we know that we need to have the correct level of calcium levels in the sarcoplasmic reticulum to be released when an action potential comes down through to bind to troponin, to move the troponin tropomyosin complex off of actin so that we can actually use that active site to form a cross bridge and cause a contraction to happen. Not enough calcium, can't get that to occur. Second reason we need this is when we look at cardiac muscle, we need calcium for the same reasons. That's going to help us maintain normal heart rhythms. So those normal heart contractions, when our calcium levels are out of whack, it can cause our heart muscle to contract either too fast or too slow. We need it for normal enzyme function. We need it for blood clotting. Without the appropriate amount of calcium ions, the blood will not clot because calcium is an important part of the cascade. So once the activity has started to get your blood to clot, you need calcium in there to continue that process. No calcium, no blood clotting. And the last one is sort of the obvious one because of the chapter we're in, but we also need to regulate calcium ion levels in the blood because that helps us with the formation of bone. So the question then is, how do we go about this process? How do we maintain homeostasis? So there's actually 2 hormones that are involved with this. They're antagonistic. One's going to be active when levels of calcium ions are too low. The other is going to be active when levels of calcium ions in the blood is too high. So they work opposite each other, and they're actually going to affect the same 3 things. They're going to affect bone, they're going to affect the intestines, and they're going to affect the kidneys. So we're going to start by looking at what happens when the calcium levels in the blood is too low. So when we look at this homeostatic mechanism, this would be the variable. And it would, as the blood circulates through, this is the control center. And the control center is the parathyroid gland. And it's going to release a hormone called PTH. Okay. PTH stands for parathyroid hormone. So when you look at it, PTH. Okay. PTH affects 3 things, and you'll notice that all 3 of these, all of the arrows are going down to this capillary bed that we've got here. Every single one of them, the end goal, these are all, so this PTH is the effector. And the end goal of all of these things is to increase calcium ions in the blood. Okay, so let's look at how each one does it. When we look at the bone, we're going to see an increase in osteoclast activity. And so these osteoclasts are going to be more active, and that's going to cause them to release more calcium ions into the blood. Okay. We're going to slide over here to the kidney, and in the kidney we have a decrease in calcium ion loss in urine. Okay, so this little dinky arrow, and size of arrows matter, this little itty bitty arrow says that we're going to have a decrease in the loss in urine. And the way we go about doing that is when PTH is around, it will cause the kidneys to release calcitriol. Okay, and you'll notice there's an arrow here. That's going to affect the small intestines, and it's going to cause an increase in calcium ion absorption in the small intestine. Okay, so now I have an increase in calcium ion that's being absorbed, and I am going to keep most of those calcium ions that were in the blood that go through the kidneys. So I'm going to keep calcium, not as many get lost, and so most of them are going back into the blood. That's why you've got that big arrow. On the opposite side of this, we have what happens, oops, sorry about that. We have what happens if we have high levels of calcium ions in the blood. Okay, so again, this is the variable. It's the opposite of what was happening with PTH. The control center in this one are the C cells, not seashells, but C cells in the thyroid gland. All right, so this is the control center. And you can see it does the exact opposite. So I already have written this in, but we're going to talk about it. So it actually will decrease osteoclast activity. But while it decreases the osteoclast activity, you can see here that the osteoblasts are still active. And so the arrow is actually moving in the opposite direction because I'm going to pull calcium out of the blood to build bone. I have less breakdown of bone, so I actually am using up more calcium than I'm releasing calcium. Also, you'll notice here that the kidneys are not being activated, and so there's less calcitriol that's being released. Notice the size of this arrow is much smaller, so that means that my intestines are not absorbing as much. So there's a decrease in calcium ion absorption. I just realized I forgot to tell you what hormone's involved. The C cells in the thyroid are going to release the hormone calcitonin. Okay, and calcitonin is causing these things to happen. Along with that, without that calcitriol, without that PTH with calcitonin active, there's going to be a loss of calcium ions in the urine. So this arrow, so much bigger than what it was here. So you can see I'm going to have an increase in calcium ion loss in urine. Okay, and so overall, all three of these activities that we see across here that calcitonin is working with are all going to cause a decrease in calcium ions in the blood. We're going to bring it back to normal. So when it's too low, parathyroid gland is active. It's going to cause the release of PTH. PTH is going to cause the bones, the small intestine, and the kidney to all bring more calcium ions into the blood to get it back to where it's supposed to be. Opposite of that, if there's too high of calcium in the blood, the C cells in the thyroid gland are going to release calcitonin. Calcitonin is going to affect the bones, the small intestine, and the kidney, cause it to either remove calcium from the blood. So here it's removing it and putting it into the bones. Here it's removing it from the blood and losing it as urine. Here it just simply isn't absorbing it. all three of these are figuring out ways to bring that level of calcium ions down. All right, hope this all makes sense. And if not, make sure you touch base with me to better understand this. Thanks for listening.